All right, cool, we're on. Good afternoon, everyone, and welcome to this talk on the serverless. Why serverless is more FinDev than is DevOps. So my name is Chui. I am an independent consultant, and the last 6 months I've been working with a number of clients based out of UK, and I've just moved to Amsterdam as well. Right now I'm based out of Amsterdam, so nice to meet you guys all. Thank you. So I've been working with AWS since about 2009. I've been running stuff in production since about, I guess, the late 2009. And as of last year, AWS also made me one of the community heroes that focuses around the serverless space because I write a lot of stuff on AWS and specifically on serverless. So I want to start talking about what do I actually mean when I say serverless. Because ever since AWS launched the Lambda service in 2014, serverless became like a word, became a thing. And I've been able to play this game whereby every time I say serverless, someone reminds me that there's still a server running behind it somewhere, which I think is just completely missing the point. And I think that Goiko says it best when he says that serverless is serverless in the same way that Wi-Fi is wireless. Sure, there's still going to be cables running around behind the scenes, but when you connect to Wi-Fi, you're not really thinking about those cables, right? They're not your problems anymore. And serverless is serverless for very much the same reason. And I think in general, when we say something is serverless, what we really mean is that it's a technology that you don't pay for it when it's not running, and that you don't really have to think about provisioning servers, auto-scaling, managing auto-scaling groups, and all of that stuff. And then you may have also heard this other related term called the functions as a service, or FaaS, which I think is a very accurate description in terms of what we do, and that's where you're going to find the poster boy for serverless, the Lambda service, and Azure Functions, Google Cloud Functions, and so on, whereby you write a very simple piece of code, a very simple function with some signature that takes in an invocation event, and then you upload it to the cloud and let the cloud take care of calling your function when something happens. It could be a customer hitting one of your HTTP endpoints, or a message being published into IoT Messenger Hub from an IoT device you have running in the wild. Whatever it is, the cloud will then invoke your function and handle those events. And when you compare function as a service with other as a service things, such as infrastructure as a service, containers as a service, and platforms as a service, the main difference, as you can see here in this diagram, between function as a service and platform as a service is in the fact that your deployment of unit and your unit of deployment and scaling is not the application itself anymore, but the individual functions that makes up your application. So by my earlier definition of serverless, we can also say that other services that are not function as a service can also be considered serverless, where system auto-scales, and you don't have to think about the server behind them. Systems such as the databases like DynamoDB, or storage services like S3, or BI systems such as Amazon Athena or Google BigQueries, all of those things magically scales beautifully, and you don't have to think about provisioning and managing the servers. On the same token, just because something is fast doesn't necessarily mean that it's serverless, I think. Sure, you got some systems that allows you to run function as a service program model on top of your own Kubernetes cluster, but if you end up having to manage Kubernetes and the EC2 instance behind that, then really you're still looking after the server yourself just to get the program models of fast. So for that, I don't think it's really fair to call them serverless because you're still very much managing the servers themselves. Not that I think a serverless itself is a badge of honor, that it really means anything, but I think it's important that we all agree on a certain set of assumptions, so when we talk about serverless, we can all make the same assumptions. Otherwise, the name just doesn't mean anything anymore. I think you find a lot of the industry thought leaders, people like Simon Wilder, who I respect an awful lot, are full believers that the serverless will fundamentally change the way that we build businesses around technology and how you code as well. But why is that? Why are so many of us so interested into the serverless paradigm? Well, for one, you get a lot of scalability, and because you're not paying for servers that when they're not running, so you're also going to find that a lot of the paid workloads will run a lot cheaper when they run on serverless. And you also get a lot of resilience out of the box as well. Lambda, for instance, is deployed to 3 AZs out of the box, and because AWS takes care of more of the responsibility for you in terms of security, your system is also going to be more secure as well. I remember when Spectre and Meltdown happened, and me and my team was busy at the time trying to patch all of our AMIs and schedule deployment to all these different clusters, and then someone from Amazon tweeted that all the clusters for Lambda has been patched for Spectre and Meltdown. Then it hit me that we weren't even thinking about the OS security for those Lambda functions we have running, because again, that's something that AWS would take care of for us. So you get blue-green deployment out of the box with Lambda, you go auto-scaling, and you also get multi-AZ deployment without having to pay for the actual redundancy yourself. So in terms of DevOps, a lot of things that we have to build ourselves for a very long time, you just get them out of the box, and you can focus on writing those business logic that your customer is asking for. But that's all great. All this automation is important, and it's what drew me to serverless in the first place. But what really made me stay and really embrace serverless is the fact that from having an idea to having something actually running in production to be able to test the idea against the market, there are just so much things I have to think about, have to do in terms of setting up AMIs, figuring out web deployment frameworks, and the CI/CD, all of that stuff. And most of that becomes either irrelevant or have been drastically simplified when I moved to serverless. So in return, I get this super highway from having an idea to being able to test the idea against the market before I decide, is this something that the customer actually wants, so that we should spend more money building it rather than dumping 6 months of work and then building something that the customer doesn't actually want. And I have this superhighway because I can minimize the amount of undifferentiated heavy lifting that me and my team have to do. And once we have something running, we also have less operational responsibilities on our shoulders, so we can continue to spend more time and energy on building the things that are important to our customers, the things that only we can do. So that's all great, and that's all very important, and why so many of us are so interested in serverless. But even behind all of that, there was something else. There's something more, I guess, more profound, something that very few people have picked up on yet. But Simon Wardley, being the thought leader he is, of course, he picked it up way back in 2015 when he wrote about how we can now have new business models built around the idea of worth-based development, where finance and development can intersect. We've been talking about DevOps as in terms of the intersection of development and the operationals, but it turns out there's another group that we're just completely forgetting, the people that are paying for all of us to be in the company. So this idea of having intersection of finance and development is what Simon calls the DevOps, where he talks about that beyond the initial investment in coding, I can create an almost variable cost business model and redirect investment to maximize return in ways that most of you have never experienced. And he knows it because he's been there, the perfect mic drop moment. So let's talk about that. Let's talk about investment, and let's talk about return on investment. I think we all know how to maximize our returns by buying low, selling high. It's not exactly rocket science. But when we think about other things that are less, I guess, returns that are not in money terms, in terms of, say, politics, you may have returns that are coming back in the form of soft power and influence. And in terms of software development, we're often dealing with returns that are something much more abstract in terms of cognitive load, how much you can reduce the amount of cognitive load required to maintain a piece of code, for instance. So refactoring is really saying that we should invest into effort now. In return, we're going to be able to reduce the amount of cognitive overhead that it takes to maintain a piece of code. And the Yagni principle says that don't invest into building things when you have no idea what the return is going to be just yet. And the same goes to other well-known principles, such as the premature optimization is the root of all evil. So in terms of understanding the return on investment from a business perspective, we obviously need to understand our revenue. And I think as a whole, we are pretty good at measuring and predicting revenue for our businesses. But then what about in terms of our investment? Well, if you're running on public clouds like AWS, then of course that's your monthly AWS bill, which you get a report back. And the nice thing about things like AWS bill is that, well, you get a really nice breakdown of how much you're spending on every single service in every single region. So you can have a very good oversight in terms of how, where those investments are going. But before you can even get there to run your workloads on AWS, you have to hire engineers to build your system in the first place, right? And engineers are getting more and more expensive, and for very, very good reason. And in the recent years, especially when in London, where I just come from, if you try to hire someone with the relevant skills with AWS, with DevOps, with containers and Kubernetes and so on, that cost is starting to get more and more serious because of the amount of competition that we see in the market. Nowadays, I think in London, you are probably looking at £600 per day to hire someone with the skill set that you actually want. So engineers are really hard to find. They are essential to your business, especially if your business is built around technology, but they're also very expensive to hire and to retain as well. And now that you hire your engineers and got your team together, you still give them a place to work. And of course, that means you need to have real estate. And from multiple surveys I've seen, commute to work or the ease of commute is one of the top 3 things that most developers use to decide whether or not to accept a job offer. And let's be honest now, most developers nowadays will have more offers than just what we're offering. So we do need to have a good real estate in places where people can easily commute to in order to attract the best talent. And of course, those real estate is not going to be cheap. And once people get there, we have to give them equipment, we have to give them office supplies and fruit baskets and all this other stuff as well. But those are just small, I guess those are your spare changes compared to everything else that you have to invest into the team in the first place. But as you hire more and more engineers, you're also going to have to give them the support structure to allow them to do their best work. And that's where you need to have good managers who are also very difficult to find, maybe even more so than engineers themselves. And they're also going to be very expensive to retain and to hire as well. And I think as an employee for a company, employment is one of the most important things that you could do as an employee to contribute to the overall, the overall health and culture of the company. But at the same time, having been involved in the recruitment process for over 10 years now, I also deeply understand just how expensive it is, not just in terms of taking time away from your engineers and your managers for the interview process, but just in terms of how much money you're going to spend as well. I think I did some research around this in terms of the agency finder fees. The industry average is around 20% for the new joiners' salary for the first year. So those costs can start to rack up very, very quickly when you want to build up a team. And the irony here is that, well, as a business, when we look at the total cost of ownership for our system, the stuff that are on our AWS bill is very easy to measure. It's what we get every month from AWS with a nice breakdown. And the problem sometimes I find is that it's well-known, it's well-observed, the phenomenon that what gets measured gets optimized. And because it's so easy to measure our cost on AWS, so sometimes we end up spending a lot or disproportionate amount of effort on optimizing the cost here, where as a business, what I really care about most of the time is my time to market, my competitiveness compared to my competitors. Can I get to the market faster than my competitors? But at the same time, in terms of where my budget is going, most of my budget is going to be to bring in the necessary brain power into the company and to retain them. I can't tell you how many times I've had similar conversations with teams whereby they look at their workload and say, okay, I'm spending $700 a month on Lambda running my workload. So if I move everything to containers, I can save myself easily $500 a month. And then, well, guess what? You don't have the expertise in the team, so you have to bring someone in to look after your containerized infrastructure, and that's going to put you back, maybe easily £10,000 a month for every engineer that you bring in. So you end up with a net loss of easily minus $9,500 per month by just moving your workload prematurely to containers. And I mentioned that the serverless can often be cheaper because you don't pay for the servers when they're not running stuff. But I think that's also oftentimes distracting us from understanding the true cost savings from serverless. Just before Christmas last year, I saw a blog post on the Register with a bit of a clickbait title. So necessary, of course, I took the bait and I clicked on the title. It talked about how, I guess, a couple of researchers, they looked at the cost of Lambda to run some workloads around doing machine learning model training and to do low latency prediction serving via batching. And they found that when they run that workload on Lambda, the cost was a lot higher compared to what it would cost to run on containers, which if you've been doing stuff with serverless before, then you know that those are workloads that are just not well fit for the paradigm as of today, given the way the platforms work. But at the same time, I'm sitting there thinking, well, for a lot of teams that we have, at the zone where I used to work, we had over 200 engineers. Most of us are not doing any of that machine learning training. We love to do them at some point, but most of us are still building API, data processing pipelines, GraphQL endpoints, and all of that. How does those findings from the paper relate to the kind of cost that we see, especially when other people who are doing very similar kind of workloads to us are reporting massive cost savings when they move from virtual machine from EC2 to Lambda. And I published a paper with Goiko a while back as well to share our findings when we did a migration from running things on EC2 to run them on Lambda. We both found massive cost savings from when we did that work. So, as you mentioned earlier, if most of your cost is focused around the people, the engineers, and the managers that are in your organization, then surely the most effective cost saving you can make is to give your engineers better leverage so that they can do more with less. And maybe you also find that you don't need as many engineers to get the same amount of work done so that you can also save on the salary side of things as well. And you get that leverage by removing all the things that your engineers used to have to do themselves and let the platform take care of them for you. Things such as doing the basic blue-green deployments, setting up auto-scaling, making sure that you have multi-AZ redundancy when you deploy your application, and to ensure that you've got good security around the operating system and the networking layers, all of that we should get from the platform these days. So you may find that when you move your workload on serverless, you may still end up costing just as much, or maybe even slightly more, but you can save a lot more in terms of productivity and in terms of time to market and so on. And I know that because for one of our previous companies, we did that migration from running things on EC2 to run on serverless. And even though we ended up with a lot of Lambda functions, the funny thing is our system wasn't really more complicated because all of that complexity was there. It was just all hidden away inside one of those boxes. So that complexity has just been surfaced when we move things into serverless. And we did the migration over the course of 6 months, while we also delivered lots of new features with the same size team. And even though cost wasn't our main driver for the whole piece of work, we did end up with some really nice cost savings by removing all the CPU cycles that we were paying for and not using. But more importantly, our time to market increased massively. Features went from taking months to deliver to sometimes being discussed, implemented, and deployed to production all within the same day. And when everything started moving faster, and you also improve the collaboration between the product team and the development team, and when things are actually getting done quickly, everybody in the company is just happier in general. And one thing that the many product owners often ask is, well, I'd like to understand the return on investment on this particular feature we're working on. Is it bringing additional revenue? How much is it costing us to actually keep running this feature? So to understand, is it worth investing further into development for this particular feature? So to work out our return on investment, we need to know how much we need to take to build this system, how long time it's going to take, and how many engineers do we need to actually go and work on this. But we also need to understand our investment in terms of how much does it take how much does it cost to run this system once it's been deployed. One of the problems in terms of working out that the cost for that individual features is that when you have things running on servers and you're paying for uptime, then the cost per transaction is highly variable based on how much throughput you're actually seeing, which is not something that you can actually control. I've got a server I'm paying $5 per hour for. And if that server is handling 1 request per second, that's my cost per transaction. But if the same server, same amount of cost per hour, is handling 1,000 transactions per second, then my cost per transaction has gone down drastically. But remember, that transaction per second is not something that I can control. I can't tell my customer to please come in at the same rate so that I can keep the same server, maximize my throughput. So as the scales go up and down, my cost per transaction is also going to do this yo-yo thing whereby as the throughput increases, my cost per transaction goes down, but when I need to scale up to get a new server up, then my cost per transaction is now going to jump back up, and it's going to go this yo-yo thing all the way through. Another thing you find is that because you've got one server that's running a lot of different things, so different features are all multi-tenanting on the same server, and this doesn't have to be just for your monolithic systems. Even within microservices, you're going to find lots of services are being used by different features. They all have to go through the same microservice. So how do you, in that case, how do you then attribute the cost for those shared services or shared infrastructure when so many different things, so many different features are depending on them? These two things together makes it very difficult for me to understand the operational costs for individual features and very hard to predict them. And you might have heard this quote from Donald Knuth before, where he said, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil, and this is probably one of the most famous quotes we have in computer science. Unfortunately, I think this is only the first half of Donald's quote, and probably the only half that you see at conferences, because every time I see this quote come up on a slide, it's always just the first half. But the second half, I think, is just as important, where Donald talks about how, but we should not pass up our opportunities in that critical 3%. The meaning, we are the pro for application, figure out where we're going to get the best return on investment before we dive in and try to optimize our application. And if your application is not so sluggish that you have to optimize for performance reasons anyway, and when you try to optimize your application, you're hoping to reduce cost, then keep in mind that the input or the investment, in this case, is going to be engineering time. As we discussed already, engineering times are expensive. Oftentimes, we tend to forget that engineering time is a very important, very big piece of investment, and we just look at the operational cost. And the output of what we try to achieve, or the return in this case, is we can cut down our AWS bill by X amount per month. So I had a conversation with someone on Twitter who talked about how he and his team, with roughly 8 developers, spent an hour talking about how they can optimize the system in order to save, what was it, $10 per month on the AWS cost. So if we crunch the maths, a conversation for an hour for 8 developers, and by conservative estimation, every developer is going to be earning about $50 per hour. So that conversation alone is going to cost them $400. So to save $10 per month, you're going to take 40 months just to break even on that conversation alone before you even go and do any work. And when you consider the pretty well-known statistics that I think something like 75% of companies would disappear within the first 3 years. So statistically speaking, most companies would have just gone bust before you can even hope to recover the cost for that 1-hour conversation to try to save $10 a month. So as Donald said, 97% of the time, these kind of small automatizations are just not worthwhile, especially when it comes to serverless, where you only pay for things when they actually run. But given how difficult it is to estimate the cost for individual features, how do we go about identifying that critical 3% where we should actually focus our energy on optimizing in order to reduce cost? That's where the pay-per-use model for serverless comes in very handy, whereby imagine I've got a system, an API, that's built with API gateway, talking to Lambda, and then talking to a DB behind the scenes. Every layer of that infrastructure is pay-per-use, and I can, with a very high degree of accuracy, estimate how much that transaction is going to cost me for API gateway, and how much that transaction is going to cost me for Lambda invocation based on the duration and memory allocation, and also for DB based on the payload size and whether or not a table is on demand. I can also work out the cost for that operation as well. So I can actually work out with a high degree of confidence the cost for that individual transaction. And we also start to see tooling coming up in the commercial space, whereby vendors now start to support monitoring at the user transaction level. So this is from Lumigo, who allows you to monitor your system at the transaction level rather than the individual functions. So in this case, I can see that one of my payment processing workflow, which involves several components, including Lambda, API gateway, and a few other things, is costing me, well, $1, and then per transaction is X amount. So I can then start to focus to find things that are either very high in cost in total because you use a lot, so I should start to optimize only those systems rather than trying to optimize things that may be very expensive, that may be more expensive on a per transaction, but happens very infrequently in the system. So this allows me to look at the transaction level to decide where in the system is it worthwhile for us to actually invest into optimizing. And this is what Simon talks about when he says the idea of the worth-based development, whereby optimization is not just about performance anymore, but being able to monitor things at the transaction level allows you to decide as a business where do we invest our engineering time to optimize things in order to save operational costs, to create meaningful savings on our operational cost. But it's even more to that, because the pay-per-use pricing model we get from the platform can actually be used by us as a business to create competitive advantage. So if you look at the different products that we have available to us, many of them are running a subscription-based model, including your Netflix, your DAZN, Spotify, and so on, whereby the business model there is that you're hoping at least, say, 80% of your customer base is going to use your platform less than what they're paying you for, because for Netflix or for the Zone, we only pay for the customers when they actually use the platform, when they watch a movie or when they watch a football match. When they're not using when they're not on the platform, then we don't actually pay for them because we don't pay for any bandwidth, not any API calls, and so on. So if 80% of the time we are in the green, then great. As a business, we're doing well. But if more and more our customers are using our system so much that is costing us more to support them than what they're paying us every month, then we're going to be in the red, and we have to rethink our pricing for our subscriptions, or maybe put some limits around usage, like you find, at least in the UK, many times when you have all you can eat mobile usage plans that actually has got a usage cap as well. At the same time, you have many other companies and other businesses that are built around pay-per-use or meter-use model, whereby you pay a premium every time you want to use the service. So Uber, for example, every time you take a ride, it would cost Uber a certain amount, but then the Uber makes money by taking a premium on top of what it costs them to support your transaction. And having developed and published a video course with Manning, and I also spent a bit of time looking at the different online learning management systems available. And you also find this split between the subscription-based models and more, meter and transactional-based models. But interestingly, for these online learning management systems, they also have a different group of customers. You've got the students who pay the platform to access content, and then the platform will incur costs when the students use them. But then you also have instructors, people like myself, who are responsible for creating content on those platforms, and we get paid either with a revenue share model, whereby we get, say, a certain percentage of the revenue that we create, or we get a revenue share based on how much time our students spend on our course. And the average, I think you get for the revenue share model is that we get 20% of what we generate in terms of revenue. So that's a small fraction of the amount of value that I create. At the same time, if you go to the other model, then you also find that very few courses actually earn any money, which is why when I published my second course on step functions, I decided to self-host it, because the model just doesn't make sense for me as a content creator. And that's why platforms like LeanPub is getting more and more popular over the years. But even with LeanPub, you only get 80% of what you generate as well. So what do you actually get for that 20% when you don't get any of the marketing, other things you get as a platform? From the platform. So as a content creator, I can't help shape the feeling that I'm always losing. But what if someone was to take the pay-per-use model and generate a new business model whereby I can get 100% of my revenue, but instead I pay a premium on the operational cost that the platform incurs when my students use my course. So instead of the revenue share model, where I only get a small slice of the revenue that I create, I get the variable cost model that the platform would get from, say, Lambda as well, and the platform still earns money by charging a premium on everything every cost that they incur to support my courses. And when you look at the cost for, say, CloudFront distribution, they are really, really cheap. And I heard from a friend of mine in the e-learning management system ecosystem that it costs them as little as 10 cents to support a student on that's taking a video course. So by allowing you to give more competitive pricing to your content creators, you're also going to be able to attract the best content creators as well. People like your West boss, who's got millions of students. He doesn't have to self-publish to get a fair share of his revenue anymore. And you can also keep the cost low for your students. And all of that depends on the ability to monitor to monitor costs at the individual transaction level, and that's how you can then create what Simon calls a variable cost business model using the pay-per-use pricing model you get from the platform. And with that, we're just about running out of time. Thank you guys very much for your time and attention.